SYNCOPETRA has made incredible discoveries with an original objective to make a magnet motor with half of the torque of a typical Faraday force motor. Numerous magnet motor perpetual motion machines are circulating in the public domain, much to the dismay of the society preaching absolute conservation of energy. We discovered powerful asymmetric magnets over a year ago that would generate orders of magnitude more wattage than anything shown on the internet today. Our bold claims are backed by experiments that are easily replicated. We are now able to produce motor forces over 100 times more powerful than anything found on the market today. More important, the potent forces are produced with no input power requirement. There are only a few possibilities. We are making another fraudulent claim of a free energy motor. Our experimenters are inept. We have discovered a way to increase flux density with the associated creation of magnetic energy. Without creating energy, we have succeeded in altering a permanent magnet's force vector, uncovering a new motor technology so potent that it may one day power flight. Our goal was and is to develop a commercial product based on what we consider to be fundamental understandings of the problems. We believe perpetual motion has been successfully demonstrated enough times. The problem has shifted from achieving spin to generating enough torque for a commercial product. Faraday force motors develop inductive direct shear forces between stator and rotor boundaries, so force and work are in the same direction. Conservation of energy, therefore, must apply. Flux density is bound on one side by a stator and on the opposing side by both the stator and an armature. Precession forces in toy gyroscopes demonstrate the fundamental principle that no energy is required to change a force vector. Working perpetual motion machines are likely to universally utilize this principle. We can imagine no other Newtonian explanation. Torque is the only requirement for angular acceleration or rotational work. Light and magnetism are both on the same electromagnetic energy scale where overlapping laws of physics apply. With this foundation, we spent many months experimenting and failed to increase the output of our asymmetric magnets. In most cases, we failed to produce any torque whatsoever. It all changed with two accidental discoveries. We realized that light and magnetic flux have many similar properties, and one very, very important difference. The similar properties. Polarization. Magnetic flux is polarized in laminations. Just like light intensity in a laser, flux densities are enhanced when polarized in steel laminations. Saturation in steel laminations occurs at approximately twice the flux density as saturation in solid material in spite of a decreased net area. Refraction. Both light and magnetic flux seem to be boundary dependent, and Snell's law may apply equally to both magnetic and light energies. At boundaries between steel and air, the permeability ratio is approximately 1,000 to 1, so flux is inherently vectored perpendicular to pole surface in accordance with Snell's law. Refractive index ratios of glass and air are less than 2 to 1, enabling more oblique boundary vectors. Sources and prisms. Systems utilizing light can be resolved as sources and prisms with boundary surfaces. Lasers are the best sources, and the other components in an optical system are essentially prisms with boundaries obedient to Snell's law. The art of magnetism transforms from mysterious to simple when prism boundary principles are applied to magnetic flux. Sources in the magnetic system are permanent and electromagnets, and the prisms are made of steel. Of course, a Faraday force armature must be modeled as an electromagnetic source with an attached prism. And the important thing, the dissimilar attribute. Light has inertial properties of mass and propagates in a straight line unless reacted on by a boundary. Unbound flux has a propensity to propagate along a curved path of least resistance. Newton's advocates might need to exempt magnetic flux from his inertia-based principles, especially in reactions involving refraction in triangular steel prisms. The prior art discloses the path of least resistance involves a specific ratio between inductive and magnetic attraction forces.